So for multiplying and dividing, it's a little bit easier. If we have mixed radicals, we do numbers with numbers, radicals with radicals. So in this case here, what we can do is we can just multiply these together. Okay, so 72 times 5, well that's going to be, what's that going to be, 3,600. Okay, so 72 times 5 is 360. And then add the extra 0 there. Now in this case here, 3,600 happens to be a perfect square because we have 36 as a factor. That's a perfect square times 100, which is a perfect square. So we end up with 6 times 10, that equals 60. You may be able to work that out in your head, but we can also break it down to smaller perfect square factors. So here, if the indexes are the same, we can just multiply the inside with inside, outside with outside. So this is 2 times 5. Okay, so it's going to be 10. And it's going to be 4th root of 3 times 4th root of 27. Okay, so 3 times 27 is 81. Oh, sorry, it's going to be 4th root here. Okay, now we should kind of know that the 4th root of 81 is going to be 3, okay, because 3 times 3, 3 to the power 4 equals 81. Now if this is not fact for you, that's okay, we want to make sure we start developing these power number facts, just like our multiplication tables. We want to know our power number facts. Now we don't need to know, 15 to the power 4 or 3 to the power 18 or anything like that. We just need to know our basic powers. So once we know that this is a perfect power 4, this just ends up being the 4th root of 81 is going to be 3. So that works out to be 30. Okay. Same with division, numbers with numbers, radicals with radicals. Since it's a plus here, we have to distribute that division. So we're going to do 6 and then 72, root 72 divided by 8. Okay, root 72 divided by 8 is going to be 6. Oops, that's not right. 72 divided by 8 is 9. Plus, there's no number here, so we're just going to do 2 divided by 1. So 24 divided by root 8 is going to be root 3. Okay, so here we're just going to end up with 6 times 3. Well, that doesn't simplify. There's no like radicals here, so this just becomes 18, the whole number part, and then there's a radical part, and we cannot group these together because this is counting ones, this is counting root 3, so that's it. For here, what we can do is we can do the distribution first, or we could do the divide first. It's probably easier to do the distribution first. Okay, so root 2 times 2, root 2 is 2, plus root 2 times root 10 is square root 20, and then we do the divide. We're going to divide into these. Now before I divide, I'm actually going to factor out the perfect square here. So I've got 20 becomes 4 times 5, so square root 4 becomes 2, and then root 5. Divided by 2, distribute the division. Okay, again, the numbers with numbers, radicals with radicals, so we just end up with 1 plus root 5. Here I would simplify the fraction first. Looks like we can simplify that first. So we end up with, there's no number parts here, so it's just 3. Root 10 divided by root 5 is root 2. Root 15 divided by root 5 is going to be square root 3. Okay, keep it under the root. We can simplify square root 27 into 3 root 3. Okay, we factor out the 9. And then 360 divided by root 360 divided by root 5. Well, root divided by root is fine. So we're going to do 360 divided by 5. That's going to give us 72 square root. Okay, so 360 divided by 5 is 72. We have some like radicals here, so we should combine those. So we end up with 3 root 2. Root 3, again, the coefficients are counted. We have 1 root 3, and we're taking away 3 root 3s. And so we end up with negative 2 root 3s. Here we're going to factor out the 36. So 36 times 2. Square root of 36 is 6. So this becomes 6 square root 2. And then we can combine the like radicals. This is counting root 2s. We have 3 of them here. This is counting root 2s. We have 6 root 2s here. So we're going to end up with a total of 9 root 2s. And then we're going to take away 2 root 3s. These are not compatible, so we just have to leave it as such. Here again, we want to simplify the radicals when we can. Okay, we could distribute first, but it's probably easier to just get rid of this times root 2 divide root 2. Well, times root 2 and divide root 2 will just undo each other. And so we're just going to be left with 3 root 6 plus root 14 plus. Okay, well, this is radical with radical, so root 60 divided by root 5 is going to be root 12 over 2. We can simplify this. These are in simplest form, so 3 root 6 plus root 14. We can factor out the perfect square of 4, so it becomes square root of 4, and then we're left times 3. Okay, so root 12 becomes 2 root 3. And then we have to divide by 2's. Those cancel out. We have no like radicals, so that's as far as we can go. That we cannot combine anything together because this is counting root 6's, this is counting root 14's, and we have 1 root 3, and none of them are the same, so we cannot combine or count them together. So this is as far as we can go. We have to leave it as such.